All right, everyone, this is a continuation of the previous class. And for today's topic, we will be using a chemistry book, Chemistry for CSEC by Annie Tyndale and Elizabeth Richile by Diane Lutig. I will send the link for the book on the channel. You can check within the comments, you will find it. So let's recap on what we did. In the last class, we did a little bit of reading up on the particulate nature of matter. And if you're out there, you could read this while asleep. You could listen to this as an audio while you're probably sleeping, while you're in your journeys and what's not. So continuing this here, our topic of today for chemistry, CSEC, will be on osmosis. Osmosis is a special case of diffusion, which involves the movements of water molecules through a differentially permeable membranes from a region of a lot of water molecules to a region of fewer water molecules. A differently permeable membrane is a membrane that allows some substances to pass through but not others. You may also find the membranes being called a semi-permeable or selectively permeable membranes. The cell membranes that surrounds biological cells is differentially permeable. And it says right here, a key fact. Osmosis is the movement of water molecules from region with a lot of water molecules. Example, a dilute suit or pure water to a region with fewer water molecules. Example, a concentrated solutions through a differentially permeable membranes. Alright. However, the particles of many other substances which may be dissolved in water are unable to pass through. When two substances, example sucrose solution, which have different concentrations, are separated by a differentially permeable membranes, the water molecules will diffuse through the pores in the membranes from more dilute solution to the more concentrated solution. The sucrose molecules, however, do not move because they are unable to pass through the pores in the membranes. The volume of the more dilute solutions decreases and the volume of the more concentrated solution increases. A good example of this is that where you can see right here. I'll give you a couple of seconds. I give you a couple of seconds so that you could watch it, look at it, and analyze it. So, for what we could see, we have a differentially permeable membranes. We have a differentially permeable membranes. Sucrose molecules cannot pass through the differentially permeable membranes. Water molecule diffuses through the differentially permeable membranes. Since water can diffuse through these things because they have extremely small atomic mass and what's not. So dilute sucrose solution, the net movement of water molecules, concentrated sucrose solutions. So water can make its way over here, if you could see from the diagram. So this figure is the theoretical explanation of osmosis. So this is a lab experiment that goes into investigate osmosis in green pawpaw. So from the diagram below, we have distilled water, as you could see there. We have the beaker and we have pawpaw strips, concentrated sodium chloride solutions. So as we move down a little bit, we have the distilled water, the pawpaw strips increased in size. Concentrated sodium chloride solutions, pawpaw strips decrease in size. So over time, through the process of osmosis, the particles eventually start to decrease. If you could think here, we move from this size here, this, let's put this thing, um, uh, I'll just use simple terms, big size to a small one. And that is very interesting. So, during the experiment illustrated in figures 12.7 and 1.28, the cell membranes of the pawpaw cells act as differentially permeable membranes. Water can pass through the cell membranes either into or out of the cells. Distilled water has a higher concentrated content or lower sodium chloride concentration than the pawpaw cells. Therefore, water moves into the cells by osmosis, resulting in the pawpaw strip becoming longer and more rigid. Osmosis, this is from the interesting facts over here. Osmosis works in the same way in your cells as it does in the pawpaw. If you sweat a lot, you lose water. This lowers the amount of water in your blood, and osmosis takes place and starts to pull water out of your cells. For this reason, it's very important to drink lots of water on a hot day or when you exercise. The pawpaw cells have a higher water content than a concentrated sodium chloride solution. Therefore, water moves out of the cells by osmosis, resulting in the pawpaw strips becoming shorter and shorter. So let's go into the practical uses of osmosis. We use the principle of osmosis in various ways. These includes controlling garden pests and preserving food items. Gardening, controlling garden pests. Slugs and snails, being herbivores, are serious garden pests which ravage many of our precious plants. The skin of these pests is a lot more permeable than the skin of most other plants. This means that they need to keep themselves moist to prevent water evaporating from their bodies, causing them to dehydrate and die. We make use of these facts to control slugs and snails in our gardens by using sodium chloride, aka table salt. A good example of this is that within the Caribbean, we have a very traditional practice wherein if we see anything like a frog, we throw salt, table salt in it, and we get rid of it. Chloride is deliquescent, which means that it absorbs water rapidly and dissolves. When sodium chloride is sprinkled on slugs and snails, it absorbs some of the moisture surrounding their bodies and dissolves, forming a concentrated solution. This causes water inside their bodies to move out and into the solution by osmosis. If the slugs and snails lose more water than their bodies can tolerate, they die from dehydration. Preserving food items. Both sodium chloride and sugar are used to preserve items. Example, meat, fish, fruits, and vegetables. We are all familiar with salt fish, salt pork, and crystallization fruits, guava jelly, and glazed cherries. Both salt and sugar work in the same way to preserve foods. They withdraw water from the cells of the food items by osmosis. This makes the water unavailable for the chemical reactions in cells which cause decay. Without these reactions occurring, the food items do not decay. Or second point, they also withdraw water from the microorganisms that bring about decay. Example, bacteria and fungi. This prevents these organisms from growing and causing the food items to decay. So figure 1.2 to 10, saltfish and decrystallization fruits are examples of preserved food items. Now let's look into some of the summary questions. And our next topic will be the three states of matter. But for now, look at the questions, and if you could answer them, you could please send it in the chat. You could please send it on the comments below. And this is all for the study prep guide today in preparation of CSEC 2025. Thank you. Hope you have a blessed day in your studies for further CSEC studies. May you have a blessed day.